Hey guys, so far we've looked at polynomial graphs and we've looked at zeros and maximums, minimums, multiplicity and behavior, all that good stuff. So today we're going to start doing something else with polynomials, and that's going to be dividing them. So basically what we're going to be doing is, as of right now, if you saw something like this, you don't really have a method to divide that. So what we're going to do is I'm going to show you a method, and it's called synthetic division. So I need you to take notes on this for sure, or you're not going to be able to get the process. So go ahead and label your notes, polynomial synthetic division, or just synthetic division. And I would write down each of these little lines as well. So what polynomial synthetic division is used for, one is to find factors of polynomials, so factors of stuff like this x cubed minus 3x squared plus 2x minus 1, which as of right now you shouldn't really be able to factor. It's also used to find zeros. Zeros can also be called x-intercepts, roots, solutions, any of those words, but it's used to find zeros. And it's also used to evaluate for a certain number in an equation. So go ahead and write those three things down, and then we're going to get into how synthetic division actually works. So here's my first example, and it wants us to divide this x cubed minus 3x squared plus 2x minus 1 divided by x plus 2. So we're going to go through the steps, and I definitely want you to write down each of the steps as we go. So the first step that you need to know is you're going to write, first you're going to, if you don't already have a box, you're going to draw this box. And then once you have your box ready to go, you're going to write down all of your coefficients in the box. So write down coefficients in box. So our coefficients are going to be all of those numbers that are in front of our x's. So on our first term, it's x cubed. If it doesn't actually show you like a coefficient in front of it, then it's going to have that implied coefficient of 1. So we're going to have 1. Our coefficient in front of x squared is going to be negative 3. In front of our regular x is going to be 2. And then our constant at the end is negative 1. So these are going to be considered all of our coefficients. It's basically all of the numbers other than the exponents that are in that first polynomial part. And then the second step is going to be to set our factor, which is x plus 2, equal to 0. And then whatever number you get, that's the number that's going to go on the outside of the box. So if we set x plus 2 equal to 0, then you would subtract 2 on both sides to solve for x, and you would get x equals negative 2. So that number is the number that goes here on the outside of the box. So what we did there is we set our factor equal to 0, and then place that number on the outside of the box. So that's the number that goes outside of the box. And then if you want, you guys can write all of this down at the same time that I'm writing it down, or if you want to wait until after I've gone through this whole problem to write down the steps, then that's fine too. So the next step is going to be to just drag down this first coefficient and just write it below the box. So we're going to write down a 1. And so that was step 3. Is to drag down the first coefficient. And So then that number that's on the outside of the box, that -2, we're going to call that kind of like our multiplier. And so what we're going to be doing is each number that we get at the bottom of the box, we're going to multiply it by the number on the outside. So we got a 1 at the bottom of the box, and we want to multiply that 1 by our -2. So we have 1 times -2, and that's going to equal -2. The place where we write that is in the next position that is available, like above the number that we dragged down. So we're going to write the -2 in our next column. So -2 goes here. So in that step, we multiplied the number on the outside of the box and we recorded it in the next column. And so then whenever you have your column, so we have -3 and -2, what you're going to do there is you're going to add the numbers in the column and then you're going to repeat the process. So add column and repeat. And so whenever you're adding the numbers in the column, we have -3 plus -2. So that's going to equal -5. And so then I'm just going to repeat the process. So what I'm really repeating is like step 4 and 5 over and over until I'm done. So step 4 is multiply whatever number we got on the bottom, which is -5, by the number on the outside. So -5 times -2 is going to be 10. And then I'm going to add this column. So 2 plus 10 is 12. Now I need to multiply that 12 by the number on the outside. So 12 times -2 is -24. And then I'm down to my last column and I'm going to add these two numbers and get -25. So then, as of right now, you have this x cubed minus 3x squared plus 2x minus 1, and it's divided by x plus 2. So right now, all you have is just the numbers 1, -5, 12, and -25. So what those numbers are going to be the new coefficients to your answer. So what happens is you're dividing an x cubed by just a regular x. So your solution, it should start with x squared. So these numbers that are in this line here, they're going to be the new coefficients for our answer. So since we divided x cubed by x, we're going to start with an x squared. And then what we're going to do is the x's that we have here, they're going to go down by 1 degree each time. So what I mean by that is we started with x squared, so then that was with my 1, and then we're going to -5. So our -5 is going to need x to the first power since the one before it was x squared. So that's going to be just x. And I'll put to the first power. You can put just x though if that works for you. And then it would be plus 12. And then that would be x to the 0 power. So that's just going to kind of cancel out and we don't have to write an x at all. And then what the last number is it's going to be called the remainder. So I know that we haven't done anything with remainders in a really long time, probably since like 4th grade when you were learning division. But that -25 that's at the very end, that's going to be called the remainder. So our answer is going to of like x cubed minus 3x squared plus 2x minus 1 divided by that x plus 2. Our answer is going to be x squared minus 5x plus 12 with a remainder of -25. Okay, so then we're going to do a couple more examples here. So we want to know if x minus 2 is a factor of x cubed plus 2x minus 3. So one thing that I want to make a note of really quick is for the factor that you're given or for the 0 that you're given, for that to be a factor or 0 of the equation, the remainder needs to be a 0. So to be a factor or a 0 whenever you divide, the remainder must be 0. So go ahead and make a note of that. And then we're going to go ahead and start setting up the synthetic division process for example 2. So we're starting with x cubed, and the coefficient on that x cubed is just going to be 1, which is what we were talking about earlier if it doesn't show you what the coefficient is. And so then the next term, normally you would see like x cubed and then x squared and then x and so on. So just like in the answer to our last problem, we need to go down by 1 degree each time. So what's going to happen is if your equation is missing a degree of x, you're going to use 0 as a placeholder coefficient. So go ahead and make a note of that. So if your equation or your polynomial just skips over a degree of x, then you're going to use 0. Okay, sorry about that. Use 0, I pressed a button. Use 0 as a placeholder coefficient. And so whenever I say that, what I'm referring to is we have x cubed, and then we don't have anything in the place for x squared, because you're trying to go down by 1 degree each time. So if you start with x cubed, then you need x squared, then you need a regular x, and then you need a constant. But since we don't have x squared, we're going to put a 0 in place for it. And then on my regular x, my coefficient is 2, and my constant is -3. So now I'm going to go through, well, first I'm going to put the number on the outside. So my factor is x minus 2. So the number that goes on the outside, if I solve for that factor by adding 2 to both sides, is just going to be a positive 2. So I need to put that on the outside. Now I'm going to go through that whole synthetic division process by dragging down my first coefficient first, getting a 1. And then I'm going to multiply by the number on the outside. So 1 times 2 is going to give me 2. Now I need to add my column. So 0 plus 2 is 2. And then multiply by the number on the outside. So 2 times 2 is 4. And now I add my column again. So 2 plus 4 is going to give me 6. And then multiply by the number on the outside. So 6 times 2 is going to give me 12. And add my last column. So -3 plus 12 is going to give me 9. So then I want to fill in all of my x's. So since we started with x cubed and we're going to go down by 1 degree of x, then our first term in our quotient is going to be x squared plus 2x to the first plus our constant of 6 with a remainder of 9. So then, if you look at my note down here, to be a factor, the remainder must be 0. So to answer the question, is x minus 2 a factor? The answer is no. So then, I want you guys to try setting up example 3, and then we're going to go through it together. But just pause now and try to set it up at least, and then if you can, go ahead and do the synthetic division process, and then you can watch me go through it and see if you got it correct. Okay, so to start setting it up, I'm going to go ahead and draw my box for synthetic division, and then I'm going to write my coefficients. So we start with x cubed, and the coefficient on that is 1, and then we don't have an x squared term, so we have to put a 0 in, and then we don't have a regular x term, so we need another 0, and then our constant is 27. So then our number on the outside in this one, it gives you x equals -3. So since it tells you x equals -3, you don't have to set it equal to 0 because you already know what x equals. So we're going to put a -3 on the outside. So then I'm going to drag down my first coefficient of 1, multiply it by the -3 on the outside, and record that in the next column. Add my column, so 0 plus -3 is still going to be -3. Multiply that by my number on the outside and get a positive 9. And then 0 plus 9 is 9. And 9 times -3 gives me -27. And then if I add my last column, 27 plus -27 is going to be 0. So then I'm going to go through and add my x's in, that these are my coefficients for. So since I started with x cubed and divided by 1x, then I'm going to have 1x squared minus 3x plus 9 with a remainder of 0. So then for the question, is x equals -3 a 0 of x cubed plus 27? The answer is yes, because we got a remainder of 0. So the last thing that we said that we could use synthetic division for was to evaluate for a number. So if we have f of -1 and it gives you f of x, then what that's telling you is that x is going to equal -1. And then we want to evaluate for -1 for f of x. So we're going to do that by doing synthetic division. I will say this isn't the only way to evaluate, but I'm going to show you how to do it that way and then show you how to check yourself. So I'm going to start by drawing my box and then writing down my coefficients. So in front of x cubed, we have a 3. In front of x squared, there's a 1 implied. In front of our x, there's a -7, and then our constant is -1. So then we're going to go ahead and we have that x equals -1, so that's the number we're going to put on the outside. Then we're going to drag down our first coefficient, which is 3, multiply that by -1, and record our -3 in the next column. 1 plus -3 is -2. -2 times -1 is +2. -7 plus 2 is -5, and then -5 times -1 is +5, plus -1 in the column, and you get 4. So then if I come back through and I add in my x's, that these are the coefficients for, then I had 3x cubed and I divided by an x, so I'm going to have 3x squared minus 2x minus 5 with a remainder of 4. So then basically when you're evaluating, the remainder is going to be the answer. So whenever we were trying to do f of -1, then whatever you get for the remainder, that's going to be that's how you evaluate it. That's what f of -1 is. So 4 is going to be our answer for this. So then what I was saying as another way to check it is, and this is something you should have seen in the past, if you're evaluating for f of -1 and you already have the equation, then anywhere that you have an x in the equation, you can just plug in a -1. So it'd be like 3 times -1 cubed plus -1 squared minus 7 times -1 and then -1. And then if you worked all of that out, if you evaluated it in the calculator, you would get 4 as well. So this isn't a step that you actually have to do unless you just want to check yourself when you're evaluating, but the answer to that is going to be 4. And so then just down here, I have a few notes that I want to make for you guys to remember about synthetic division. So the first thing is whenever you're writing your coefficients and you're missing one, you're going to want to use 0 as a placeholder coefficient. And I am actually going to try to type all of this so that it's easier for you guys to read. So, okay. So what we ended up with is whenever you're writing down your coefficients and you're missing a degree of x, so like if it jumped from x cubed to a regular x or x squared to a constant and it didn't have that degree of x in there, then you're going to want to use 0 as a placeholder coefficient in that scenario. Our next note is to be a factor or a 0 of the polynomial, the remainder must be 0. And then our last note is when you're evaluating these, the answer is the remainder. So that's referring to like what we did up here. We were evaluating for f of -1. So when x is -1 in this equation, and our answer was the remainder. So that's just a few examples of synthetic division. I'm happy to do more examples in class if you guys want to see more. I will say this is a topic that whenever you see it for the very first time, you kind of are looking at it as if it doesn't make any sense and you're just pulling numbers out of nowhere. That's not really the case. You are going to use that specific process every single time that I have detailed on this slide, where you have to write down the coefficients, set the factor equal to 0, and put that number on the outside of the box, drag down the coefficient, and then multiply by the number on the outside, and record the number in the next column, and add. And so I know that was a quick way of going over all of that, but that's going to be the same steps that you use every time that you're trying to do synthetic division. So try practicing some of these and see if you can get it on your own, and then we will discuss more in class as well.